after we've talked a little bit about distance and midpoint, I want to start looking at parabolas and circles. In Chapter 9, Section 1, we look at parabolas, and we've spent parts of different chapters so far in Algebra 2 Part 1 and in Algebra 2 Part 2 looking at parabolas and their features on a graph. And so it just says, know that the graph of y equals ax squared is a parabola. A parabola is a U-shaped graph like this, and it opens up or down. So far we've only worked with parabolas that open up or down, and we're going to specifically look at parabolas that have a vertex of 0, 0. Okay, so if I were to take this y equals 4x squared and graph it, I would want to make a table of values. Okay, and I would want to pick out different x values to plug into my table. I'm going to pick the values -1, 0, and 1, just because I want to pick negative numbers as well as positive numbers to see what it does in the graph. And you could pick different values, and you could pick more values. We're just going to see what these values give us. So I plug these into my equation. -1 squared is 1 times 4. I get a y value of 4. I put 0 in there. 0 squared is 0 times 4 is 0. If I put a 1 in there and square it, I still have 1 times 4 is 4. And if you'll notice that we have y values that repeat. You're going to see 4 again in your table. And so that tells me in the parabola that I have enough points to plot the whole graph. Okay, I'm going to get on both sides of the axis here. So -1, 4 is up here, 0, 0, and +1, 4. Okay, so you've got points on both sides of that y-axis, and you're going to have a U-shaped graph. I kind of missed that point. But you've got a U-shaped graph. That's what a parabola looks like. And so I know that that parabola opens up. Okay, you could probably have looked at the equation, hopefully from what you've done so far with parabolas, that you would have guessed that that opens up. Because the coefficient in front of the x squared was positive, we expected it to open up. An axis of symmetry, just as a review for you, the axis of symmetry is that line. In this case, it's a vertical line, and it goes through the vertex, and it cuts the parabola in half. If I were to fold that parabola on that broken line, on that axis of symmetry, it's going to match up on both sides of the line. Okay? Now, to name the axis of symmetry, we would say axis of symmetry. Okay, because it's a broken line, it's a line, so we don't just put a value with it, but we write an equation. It's a vertical line, so it's x equals, and the vertex right here, the vertex is at 0, 0, and the x value is 0 there. So the axis of symmetry is going to be x equals 0. Okay, that's what we did earlier in earlier chapters, and you did some of that in Algebra 2 Part 1, and we've actually done some of that with what we've done this year. On a parabola, each point is equidistant from a point called the focus and a line called the directrix. Now, we have not talked about what a focus and a directrix is yet. And what we're saying is I might have a parabola that looks like this. Well, we have a point inside the parabola that's called the focus, got a capital F there, and we have a line that's outside of the parabola that's called the directrix. And the distance from the vertex of the parabola. Okay, the distance from that focus to the vertex and from the vertex to the directrix, those distances are going to be the same. And we call those the focal length. Okay, so there's going to be a distance this is going to be the same from that vertex to the focus as that vertex to the directrix. And every point that's on this parabola, that same feature applies. So if I took a point out here at P, the distance from P to that focus, that distance is the same as that point to the directrix. It's the same distance. I could pick a point over here on the parabola. If I measured the distance from here to the focus and here to the directrix, it would be the same also. Every single point on that curve has that same feature, that same focal length. The focal length changes, but it's the same value, the same distance in every direction. Okay? So what we're adding to our parabolas is that you're going to now talk about the focus, and you're going to now find the directrix as well. Okay, you're also going to consider this type of a parabola. This says x equals 4y squared. Okay, and notice up here it was the y that was by itself, it was y equals, and the x variable was what was squared. Well, now here we've switched them around. Y is being squared and x is not. Let's see what that does to our parabola. Okay, so we've got an x and a y. This time I would be plugging my values in for the y and not for the x because it's the y that's the independent variable. So I'm going to put a value of -1, 0, and 1 in for y. When I square -1, I get 1 times 4. When I square 0, I get 0 times 4. And when I put the 1 in and square it, I get 1 times 4. Okay, and now you're going to see the x values repeating. It's x that's going to repeat in your table. So if I plot these, 4, -1, 0, 0, and 4, +1. So now you get the points here, and when you go to graph those, you've got a U shape still, but now it's going to the right. So this graph up here just turned, and now it's going that way. So our axis of symmetry now is a horizontal line. That is an axis of symmetry. Because it's horizontal, we would name that axis of symmetry y equals 0. When it's a vertical line that's your axis of symmetry, it's x equals 0 in this case because the vertex is at 0, 0. When it's the parabola is going left or right, it's a horizontal line, so it's y equals 0 in this case because the vertex is still at 0, 0. Now, if I were going to find the focus and the directrix, we kind of need the formula on the next page, so I'm not going to find that yet. Okay, let's see what happens. If you turn the page here, here's your formula for the focal length. Okay, it says that focal length, that distance between the vertex and the focus, or that vertex and the directrix, that C value, is this formula right here. It says the absolute value of A equals 1 over 4C. So when I look at this example here, it's going to ask me to graph it and identify these features, the focus, the directrix, and the axis of symmetry. Okay, the A value is your coefficient here. So the absolute value of A is equal to 1/8. Okay, so I'm going to set that equal. The absolute value of A, this 1/8 is equal to 1 over, the absolute value of 1/8 is A. It's equal to 1 over 4C. The absolute value of a number, that's the distance from 0. So how far from 0 is 1/8? Well, that's just 1/8. Okay, equals 1 over 4C. Okay, you can see the ones are the same. To get C to be 8 here, I would have to have C equaling 2. 4 times 2 is 8. So my focal length is 2. Now we'll come back and use that in a minute. But I'm going to make a table of values, just like I did on the previous page. This time I'm not going to use 1 or -1 because if I square that, I'm going to take it times the fraction 1/8. That's really hard to graph on this with 1/8. So I'm going to pick something a little bit bigger. I'm going to pick a -4, a 0, and a +4. If I plug in a -4 and square it, I get 16. 1/8 times 16, 16 over 1, that's going to be 16 over 8, which is 2. If I put a 0 in and square it, I get 0 times 1/8 is 0. And if I put a +4 in there and square it, I get 16 again. I'm going to get 2 again. So I go ahead and I graph this. I got -4, +2, 0, 0. +4 is at +2. So your graph is going like this. Notice that the parabola really, instead of being real skinny when we had coefficients like 4 on the front page, now it's gotten much wider because our coefficient is a fraction 1/8. And as that coefficient gets smaller and smaller, you're going to see that parabola get wider and wider. Okay, so to find my focus, okay, the focal length is 2 units. So we just, from the vertex, we're going to go 2 units up, and we go up because the focus is always inside of the parabola. That point is at 0, 2. That would be my focus. And my directrix is going to be the opposite direction. So if I go 2 below the vertex, The directrix is a line. Now that's a horizontal line, so that's y equals. What does y equal everywhere on that line? Well, hopefully you said -2. And my axis of symmetry is still going to be that vertical line in this case. That's going to run right through the vertex. So that would be x equals 0. Notice that the axis of symmetry and the directrix are always perpendicular to each other. The focus is always inside of the parabola. The directrix is always outside of the parabola. Okay, I'm going to do one more quick example for you. Okay, here I've got x equals, so when I make my table of values, I want to plug my values in for y. And I'm going to use -4, 0, and +4 again. Because if I put the -4 in there and square it, I get 16. What's 1/16 of 16? 1/16 times 16 over 1. That's 16 over 16, which is 1. I put a 0 in there and square it. I get 0 here. 4 squared is 16. That's going to be a 1 again. So I'm going to graph 1, -4. I'm going to graph 0, 0, and I'm going to graph 1, 1, 2, 3, 4, +4. Okay, so this time my parabola is going to open to the right. Okay, this time it's the y squared, so it's either going to open up left or right. Because 1/16 is positive, it's opening up right. If this were negative, it'd open up to the left. Okay, to find my focal length, I take that 1/16, the absolute value of A is 1/16, is equal to 1 over 4c. Absolute value is always positive. Okay, what does the c value have to be to make these two equal? And hopefully you said c is equal to 4. Okay, so to identify my focus, remember the focus is always inside here, so 4 units from the vertex would be right here. That would be at 4, 0. Okay, 4 units on the other side would be my directrix. Okay, that's a line, and this time that's a vertical line, so it's going to be x equals, and that's going to be -4. And my axis of symmetry would go right through the vertex and through the middle of the parabola. That would be y equals 0. Okay, so we've identified all those features on that parabola. Go ahead and see if you can finish the bottom 2 graphs.